Okay, so today we're going to be doing a little exploration on talking about the properties of parallelograms. One of the things that we need to be able to do is explore these in more detail and see how they relate to specific types of parallelograms. So I'm going to partner with you and your shoulder partner, or possibly you're working with a group of 3, depending on how many people are in your group today. And we're going to do this exploration together, at least for the first part. That way, I can kind of help you along and help you understand some of the instructions. Plus, there's some preview teaching to go along with it as well. So what you're going to do is you and your shoulder partner or group of 3 are going to run the video at the same time. So you're each going to be watching the video as we go along, but you're going to pause at the same time. You're going to stop. You're going to work together, talk about some things, make some observations together, and then you'll come back and each watch your respective videos as we go along. So just keep that in mind, that you're going to be pausing and doing that. Now, the first thing that we want to do, though, is we need to prep up some patty paper. So if you're watching this for the first time in class, then of course you're going to have some patty paper and you're going to be doing these explorations in class. If you're watching this after the fact because you were absent or you're just reviewing it, then you'll just follow along with the drawings after they're completed. So I gave you 3 pieces of patty paper. So you're going to grab your patty paper, and the first thing we want to do is we want to take it and we want to fold it into 4 sections. Okay, so we're going to take the patty paper here, you can see, and we're just going to fold it in half, like that, and then we're going to take it and we're going to fold it in half again like that, so that we get 4 nice squares. And then you're going to take your scissors and you're going to cut those up into 4 separate pieces. So you want to do that with all 3 pieces of patty paper that I gave you, so that you have 12 little squares. That'll be enough for you to complete the entire activity. So the first thing that you and your partner and or team are going to do right now is you're all going to pause the video and you're going to prep your patty paper. And then when everybody is ready to go and you've got your patty paper squares cut and you're set and ready, then everybody starts the video again at the same time. So you're each watching the video on your own computer so you can get the instruction individualized. But then when I tell you to pause, you'll come out and you'll kind of talk together and work together. So make sure your patty paper is prepped and ready to go. Go ahead, and the video will pause now, actually automatically for you. It'll pause. And then when everybody's patty paper is prepped and your partner or team are ready to go, then go ahead and everybody starts the video again at the same time. Okay, so you're working on patty paper prep. So I wanted to start with showing you a little bit of a family tree. This is the family tree for quadrilaterals. So by the most generic definition, a quadrilateral is any shape that has 1, 2, 3, 4 straight line shapes and it's closed. It's a polygon. Polygon means it's a straight lined closed shape. And so a quadrilateral, quad obviously meaning 4, that describes pretty much every type of quadrilateral. But there are specific relationships and families that exist. Like, for example, we've been talking about parallelograms, right? And so we found these kind of shapes here and we looked at some of those properties, and you can see that there are other members of this family that sort of exist right in here as well. And so we're going to try to determine, what makes this one different than this one, if they are, and, or how are they related to this one, and is this guy different here, and how does this relate to this, and what does it look like over here? So we've got to try to figure out how do we put the family together. So our main focus today is going to be working on the parallelogram family, and then we'll build out the other parts of the family of the quadrilaterals at another time. Okay, so this is the exploration paper that I gave you, and you've got this out in front of you. Just a couple of quick observations. As I write some extra notes down on here, you're definitely going to want to write those notes down as well. And then you're going to be doing some things independently. Like I said, you'll be pausing and working with your shoulder partner or your group of 3 as we move along. So we are trying to determine some quadrilateral properties using triangles and transformations. Now, some of you, when you were looking up the properties of parallelograms on Google, you came up with this idea that a diagonal cuts a parallelogram into 2 congruent triangles, which is definitely an observation about diagonals. It is not considered a property of all quadrilaterals, but it does exist. I mean, all parallelograms, but it does it does in fact exist. And so we're going to use that idea along with transformations, which we talked about last semester. These are our translations, rotations, and reflections. You can see that we're going to be doing rotations today, and we're going to be rotating 180 degrees. So when we do rotations, we need a degree amount that we're rotating, and of course we need a point in which that we would center our rotation. So in these, it's going to be rotating around point M. And then we will be creating some parallelograms from these triangles. So of course, if we start with one triangle and then we make a copy of it, then that would be obviously a congruent triangle. Okay, so that's what we're going to be working on here. So the first thing that we want to do is we want to take this scalene triangle. And of course, scalene means that you've got three sides that are not congruent. So you can see that this has a single congruency marking, a double congruency marking, and then this one has no congruency marking. And we're able to actually count that distance of 1, 2, 3, 4, 5, 6 along those lines like that. So you can see that that one is clearly longer than the other two sides. And so we have a scalene triangle because all three sides are different. Now I want to explain a couple things about the markings because you're going to see these throughout the exploration, and so I want you to understand how this particular worksheet works. Obviously, the congruency markings, that's pretty similar. We've talked about that. Anything with a single congruency mark would be the same as anything else with a single congruency mark in double, and so on and so forth. It's the angles that I want you to see. So you can see that there's a little hollow dot here in this angle and a solid dot here in this angle, and then there's an X here in this angle. This is the notation that this particular worksheet uses to say, you know, this angle has a certain number of degrees, and we're going to represent that with a hollow circle. And then this angle has a certain number of degrees. We're going to represent that with a solid circle or a solid dot. And because this one's hollow and this one's solid, what we're saying is that these two angles here are not congruent. They don't have the same measure. Okay. So anything with the same symbol would indicate the same measure. Same symbol would indicate the same measure. And then of course, when we use an X down here, we're saying that's different than both this one and this one. So in this particular triangle, we've got three different angle measures that you can see here indicated by the hollow circle, the solid dot, and then of course the X. Okay, so that's what those notations mean. They indicate angle measures without actually giving us numbers, degree numbers. It just says, hey, these three angles here, here, and here all have different degree measures. Okay, so let's start with our first piece of patty paper. So I have a piece of patty paper over here that I'm gonna grab and bring up here just to kind of sort of give you a ballpark idea of what we're doing. And so your patty paper should resemble mine pretty close. And what you want to do is you want to center your patty paper so that point M is kind of in the middle of your patty paper. You want to center your patty paper so that point M is in the middle of it. And then what you're going to do is on your patty paper, you are going to actually, whoops, hang on one second, let me turn that off. You're going to actually trace the triangle and you're going to create all of the markings. Okay, so you're going to put the angle markings in there and the congruency markings and all that stuff. You're going to trace the triangle and put that all in there. And then you're going to actually take your patty paper and as per the instructions, we want to rotate our patty paper 180 degrees. Now, if you recall, you know, when we talked about rotating, we needed a direction. But it doesn't really matter whether we go 180 degrees clockwise or counterclockwise, we're going to end up in the same place. And so you can see here, I'm going to take my patty paper and I'm going to start to rotate it. And actually, even on my screen, look, you can see the degrees. If you look at the little degree up there, see it says 34 degrees. Now it says 45. See right there where my little circle is, 34, 45. So I can keep going. So once I rotate all the way, click, you know, one way all the way around, that's 90 degrees, right? So I'm just going to go back real quick so you can see, right? So I'm starting at 0 degrees and I rotate around. There's a 90 degree rotation. So then I got to keep going again to 180 degree rotation. Now, my triangle obviously isn't traced on here. I'm not able to do that, but you will have traced your triangle. And so when you do 180 degree rotation, whether you go clockwise or counterclockwise, it doesn't matter, then you will be able to see your triangle. And of course, it should end up, you know, kind of somewhere up here-ish like that. And then what you want to do is mark those points and copy that triangle from your patty paper onto your actual paper itself so that you have a parallelogram that's been created out of those congruent triangles. So again, once you've traced your triangle here, this scalene triangle, you should have something that kind of looks like this up here, and then you need to make sure to mark in all the markings. So we're going to pause the video right now, and I want you to complete that. We're just going to do this one right now, and then we'll check it with everybody and make sure we're all on the same page and everybody's doing it correctly, and then I'll clear you to do the other 3 examples. But let's just do this one first and then check it, okay? So everybody's going to work on creating that right now with your shoulder partner or your team. The video will pause, and then once you all have this, then you'll all start the video again, and we'll check, make sure you're right, and then we'll move on from there. Okay, so this is what you should have drawn on your paper here. You should have created this parallelogram and filled in the markings. So you've got the 2 congruency marking should be across here, and the 1 congruency marking should be across here. Here's your solid dot, your hollow dot, your X, all that should be filled in. You're going to do that as you do each one of these. Make sure that you copy all of the markings across. And, you know, just so that you can begin to see how that works, you can see that this triangle that we copied in up here, right, of course, is a duplicate, a copy that we made of this triangle right here. But again, you begin to start to see these parallelogram properties play out. Like, look, for example, this is a, measure X degrees, a measure, I don't know degrees, but we represent it with an X. And then look across the way here, that's an X degree, right? And so, of course, these are considered opposite angles, right? And this angle right here is opposite from this angle right here, but you can see that it's a combination of a solid dot and a hollow dot, a combination of a solid dot and a hollow dot. And of course, you can see that there's opposite sides that are congruent. And so you can see how these congruent triangles begin to build these parallelograms, and that's what we're going to be looking at with these explorations, okay? So the first thing that you need to do now is you need to complete this this same thing that we did here with the patty paper on this first one. You need to now do that with these other 3 examples right here. So you want to rotate each one of these other 3 triangles right here about point M using your patty paper. So you set up your patty paper so it's centered around point M, and then you're going to rotate it 180 degrees, and you're going to recreate all of those. So the video will pause now, and then as a team or a shoulder partner pair, you're going to make sure that you have all 4 of those drawings completed, and then we'll go into the next aspect where we start to begin to talk about the observations that we can make in regard to these parallelograms that we're creating. Okay, so go ahead and get the other 3 examples done here. You're going to use a clean piece of patty paper for each one. That's why you have 12 pieces of patty paper, so that you can create each one of these and rotate them. Okay, so you've completed the patty paper rotations for the other 3 examples. This is what you should have come up with for this first one right here. So check your work and make sure you got it right, and you've got all the parts labeled in there for the second one here, and of course for the third one here. If you need to pause the video just to take a second to just make sure you got all your work done or make any corrections, now would be the time to do that. If not, then we'll just keep moving on. So I'll give you a second if you need to pause. Okay, so you've got your 4 rotated triangles on here now that you can see. Now we're going to start talking about the different properties of these quadrilaterals. You can see properties, properties, properties. And we want to evaluate them in terms of sides, angles, and diagonals. And we're going to do this throughout this exploration. So you can see here that one of the first questions is what quadrilateral is formed in all 4 of these examples. We're actually going to come back to this this answer at the end. First, we want to do the exploration and see what we can come up with. So what you're going to do is you're going to try to determine if the properties listed below, all of these properties that you're going to see listed down here, exist in all of the examples. All right, so they've got to exist in all of the examples. If even one of them is wrong, then you'll find that you have to mark it as no. So the only time that you're going to mark yes in one of these boxes here, or check yes on the questions on the right side of the screen, is if these properties exist in all of the examples. Okay, so the first thing that we want to talk about, and there's actually going to be a little note taking. This is actually going to be important teaching for you coming up for the next section after we talk about the properties of quadrilaterals, is how to determine whether or not the opposite sides are parallel. Okay, and that's of course the symbol for parallel. You've seen that a number of times. So in each one of these situations, you know, we think these lines, these sides might be parallel, but we need to actually be able to prove that, and that's something that, like I said, is going to come into play on our next topic in regard to quadrilateral. So let's make some notes over here, because this is really, really important that you know this. Parallel lines have the same slope. Now, slope was a concept that you learned in Algebra 1. Slope, of course, is rise over run, or it's the change in the y values over the change in the x values. And so this idea of, you know, when a line has, when a line goes from one point to another point, there's a change up and down and a change left and right that gets us that line, and so we calculate that. So we're going to actually take a look at that on this first example right here. And so I actually want you to draw these notes in here, but let's take the two congruency mark side. What we want to do is we want to figure out what's the slope of this line or this side right here, and what's the slope of this side, and do they match? And so we can start at either point here and work our way here, or backwards the other direction. When you're determining slope, it doesn't matter. I'm going to start down here and work my way up. So if I wanted to determine the slope, I could start at this point and I could say, okay, I need to go to the right 1, 2, 3, 4, and then up 1, 2. So I went right 4 and I went up 2. And so when we write our slope, we always write the up and down number on the top and the left and right number on the bottom. And so this would be up 2 and right 4, and we would simplify our fraction for a slope of 1/2. So this two congruency mark line right here has a slope of +1 over +2. And so we would need to check the line, the slope for this line right here, and we could do that by saying we're going to go up 1, 2, and then right 1, 2, 3, 4 again. And so you can see, again, we're going up 2 and right 4, so that gives us, again, that same slope of 2 over 4, or +1/2. And so since these two lines have the same slope value, then we could say that those two sides are in fact parallel. Now, again, if we're talking about here, are the opposite sides parallel, then of course we need to also verify that these lines are parallel as well. So what I want you to do right now is, the video is going to pause. I want you to do these same kind of little swoop circles, and I want you to try to calculate the slope for this line and this line, and you can just kind of jot that in on your paper, and then we'll come back and take a look at that. You can work with your partner to determine, is the slope for the one congruency sides the same? And if that's the case, then we would have opposite sides are in fact parallel. So the video will pause now, and you'll figure out what the slope for the one marked side is. Okay, so you can see that the single congruency marked sides are also parallel. You should have come up with a slope of -1 on each of those, and that of course comes from a down 2, right 2, down 2, right 2 here. You can see that in the pink markings. And of course, when we go down, we're doing a negative, and also when we go to the left, we're also doing negative as well. And if you need a refresher on slope, we can work on that as well. But hopefully you'll get that refresher as you work through these problems. This is something that I do want you to do. I want you to actually practice writing out this slope on each one of these examples, on the entire exploration, all the pages, because this is going to be an important skill for you to be able to do. You're going to need to be able to find the slope of these lines and use that to justify some reasonings and some things. So I do want you to get some practice in. So on each of these examples below, as you are trying to determine if opposite sides are parallel, because remember, it has to exist in all of the examples, I want you to make your swoops and write out your slopes so that you know exactly, is this line parallel to this line, and what slopes do you come up with, okay? So you'll be doing that. Let me talk about the other ones that you're going to do here, and then the video will pause. You'll do some work with your shoulder partner or teammates, and then you're going to try to decide yeses and nos for the side properties here, and then you'll answer the question on the right side of the screen to move forward. So we've talked about opposite sides are parallel. Let's talk about opposite sides are congruent. That one should be pretty straightforward and easy to figure out. You have congruency marks, so you can see whether or not those are congruent.
Let's talk about adjacent sides. Okay, so we're pretty clear on what opposite sides are, right? You can see that this 3 congruency mark and this 3 congruency mark are opposite sides because they are across the room from each other. So then that makes the adjacent sides, just like adjacent angles, ones that share a corner. So that means that this single congruency side and this double congruency side would be considered adjacent to each other. Why? Because they meet at this corner. So adjacent sides of a parallelogram meet at a specific corner. So then the question that you have to ask yourself is are the adjacent sides in each one of these perpendicular? In other words, do they meet at 90 degrees? And we can see here clearly that these do not meet at 90 degrees. Again, remember, like, for example, with this example right here, this is not the entirety of the angle where the adjacent sides meet, right? The adjacent sides meet here and here, but that angle is made up of both this angle here and this angle here. So really, the degree measure for where these two adjacent sides meet is 90 plus solid dot. So 90 plus anything is going to be more than 90, which means that these two adjacent sides right here would not meet at 90 degrees. So you're going to go through and evaluate and see if the adjacent sides meet at 90 degrees. That's what it means for them to be perpendicular. And then, of course, this one's pretty easy. Are all 4 sides congruent? Are all 4 sides congruent? So you're going to evaluate each one of these here, make sure that you do your slope markings, and then you're going to check yes and no on your paper, and then you're going to answer the question on the right side of the screen. That will allow you to move forward. So work with your shoulder partners, work with your teammates to determine on each of the examples below, are the opposite sides parallel? You'll do that by making sure to show your slope swoops and making sure to write out your slope calculations, and then checking also for opposite sides congruent, adjacent sides meeting at 90 degrees, and are all 4 sides congruent themselves, okay? So that's what you're working on right now. So hopefully you answered that yes, opposite sides are parallel in all of the examples. Opposite sides are congruent, yes, in all of the examples. Adjacent sides are perpendicular, no, that doesn't exist in any of the examples, and none of the examples that we looked at over there are all 4 sides congruent. So hopefully this is what you came up with for your answer for the question and your check boxes on your paper. I want to talk to you a little bit more about slope, because again, this idea of slope is going to be really important as we move into the next section of our quadrilateral. So I want to review some things with you, and then I'm going to actually ask you a couple questions on slope. So pay real close attention as we just go over this again, just to make sure that you are tracking along with us here on this idea of slope. First off, again, just a reminder that all parallel lines are going to have the same slope. So if lines are parallel, they have the same slope. You'll need to use that information. Now, let's talk for a second about this one right here, these vertical lines with the single congruency markings. You'll notice that the slope came out undefined. Okay, this is a vertical line, right? Runs straight up and down, and vertical lines always have an undefined slope, and you learned this again in algebra, but here's the reason why. It's because there's no left or right movement. You can see whether I start here and go down to, or start here and go down to, since there's no left and right movement, I'm going to have a 0 in my denominator. And as you learned in grade school, when you're dividing, you can't divide by 0. That's an illogical statement. If I had some pizza and I wanted to, break it up amongst no friends, well, then I'm not actually dividing it up, so it doesn't make sense. It's an illogical statement. And so all vertical lines, since there's no left or right movement, are always going to have an undefined slope. Okay, and then again, you can see this here, and it doesn't really matter whether we go up or down. First, if I start down here and I decide to go up 2, that's still going to put a positive number in my fraction, but I'm still dividing by 0 because it's a vertical line, and so my slope will always be undefined. The other one that I wanted to point out to you to make sure that you were aware of was the idea of a slope of a horizontal line. Now you'll notice here that there's no up and down movement. There's no up and down movement, right? So when we talk about the slope of a horizontal line, because there's no up and down movement, you're going to have a 0 on the top part of your fraction. And so then as we're moving across left and right, we're still dividing by a number, and we end up with 0. And again, if I go back to the pizza analogy, this is actually a logical statement. I've got 3 friends and I want to break up no pizza amongst my 3 friends. Well, how much pizza does everybody get? Everybody gets no pizza. There's no pizza to break up, but at least we have the 3 friends to break that up. I mean, if there were pizza, we could get pizza slices, but in this case, we have no pizza. We have 3 friends. It's okay for us to, you know, say, well, you know, until we get pizza, everybody's getting 0 slices. So when you have a 0 on the top part of your fraction or the top part of your division problem, because fractions are division problems, this is 0 divided by 3 is going to result in 0 pizza for everybody. So horizontal lines are always going to have a slope of 0. The last thing that you need to recognize also here is that, again, it doesn't matter whether we go up and right or down and left. So like, for example, on this slope right here, I decided I was going to start at this point and work my way this direction. So I went up 1, 2, 3, and then right 1, 2, 3. That gave me a positive 3 over 3, which simplifies to positive 1. If I start over here and I go down 1, 2, 3 and left 1, 2, 3, I end up with the negative over negative, which is still a positive value. And so in that particular case, I still end up with a positive 1, which shows me that these lines with the 3 congruency marks have the same slope. And you can also see that same idea of directional changes in positive and negative numbers on this example right here. You know, for this 2 congruency marked lines, I went right 1, 2, 3, 4, and up 1. So that's a positive 1 and a positive 4. Over here, I want left 1, 2, 3, 4, and down 1. That's a negative 1 and a negative 4. But still, a negative divided by a negative is always going to result in a positive. So you can see here, I've got positive 1/4, positive 1/4. That means that these lines with the double congruency marks have the same slope, and lines with the same slope are always parallel. It's going to be a really, really important concept for you to be able to find slope and use slope to defend parallel lines as we continue to move through this particular thing. So I want to ask you a few questions about slope just to see if you were paying attention here. Feel free to work with your group mate, your team, if you want to try to answer these questions together, but everybody answers the questions individually on their own computer. So now we want to explore the angle properties of the quadrilaterals. And again, we're going to do this in all 4 examples. We're going to look at all 4 examples for the angles. Since my screen is just kind of centered here, I'm just going to talk about this one right here. You'll check the other 4 and then decide what you want to box in here, check mark, and then you'll answer the question. Opposite angles are congruent. Okay, so again, now we're not dealing with actual degree measures on here, but we are dealing with the symbols that I mentioned earlier. So for example, you can see here on this particular example right here, this angle right here is measured with a hollow circle. This angle right here is measured with a hollow circle. So then it would be legitimate to say that this angle and this angle are congruent because they have the same marking as far as their size goes. This angle of the parallelogram is made up of a solid dot and a hollow dot. And this angle is combined of a solid dot and a hollow dot as well. So when you take these 2 angles and combine them together, and you take these 2 angles and combine them together, you get solid and hollow and solid and hollow. That would make those opposite angles congruent. So in this particular example, the opposite angles would be congruent because of those markings. Okay, so that's how you determine the opposite angles are congruent. Now let's talk about this one. This one's a little tricky, but I think it's pretty cool with the markings. It makes pretty good sense. And this one is actually referenced right over here as well, and we can look at it in this example. We'll actually look at it 2 different times. So consecutive angles are supplementary, right? They add up to 180 degrees. Again, consecutive angles are the angles that are in a row, like this one here and this one here add up to 180 degrees, or this one here and this one here add up to 180 degrees. So then the question becomes, well, if I don't have any numbers, how do I know that they're going to be supplementary, that they're going to add up to 180 degrees? Well, we're going to use our triangle angle sum theorem for that. Let's, I'm gonna zoom in over here. Let's take a look at this example right here. All right. Let's just focus for a second on this top triangle right here. What are the 3 angle markings that make up the 3 angles of that triangle? Well, we've got an X, a hollow dot, and a solid dot. You see that? So in this top triangle, we've got an X, a hollow dot, and a solid dot. And we know that all the angles of a triangle always have to add up to 180 degrees. So that means that X plus hollow plus solid must equal 180 degrees. Well, take a look at these consecutive angles right here. You've got an X and a hollow and a solid, which means that this angle and this angle right here, our consecutive angles, must add up to 180 degrees, because if x hollow solid in the triangle adds up to 180 degrees, then x hollow solid must add up to 180 degrees. You see how that works? So you can see it, it's kind of written in right here, and that comes from the triangle angle sum theorem. So if we come back to this example over here, we can see that in our original triangle right here, we had two hollows and a solid. We had two hollows and a solid. So that means that we're going to need two hollows and a solid in our consecutive angle. So if we look at this angle here, there's a hollow, and then here's a hollow and a solid. So then those clearly add up to 180 degrees, because we've got two hollows and a solid consecutively. Again, with these angles right here, you can see that we have two hollows and a solid, two hollows and a solid. Again, consecutive angles here, two hollows and a solid. Consecutive angles here, two hollows and a solid. So two hollows and a solid added up to 180 degrees in that original triangle. So then two hollows and a solid would add up to 180 degrees in those. So you're going to check the other ones and make sure that that adds up as well correctly. And then the last one is, are all four angles 90 degrees? And again, remember, 90 degrees would need to be marked for us. And just keep in mind when you're looking at the 90 degrees, you know, this 90 degree marker is just representing this portion of the angle, but the whole angle of the parallelogram is this entire thing, which includes another portion of another angle right there. So keep that in mind as you're looking through these. So you'll answer the question on the right, you'll check mark these, work with your shoulder partners and your teammates to come up with the angle properties. We'll answer those questions. We'll talk about diagonal properties, and then we'll be moving on to the next one. As you looked at all four examples, it should be pretty obvious that the angles were congruent, and the opposite angles were congruent in each one. It should also have been pretty obvious that all of the consecutive angles did add up to 180 degrees, and then we did not have any of them that had four 90-degree angles. And so that's what you should have answered your question and completed your check boxes accordingly. All right, so the last one we need to talk about are the diagonal properties. We want to explore the diagonal properties of these shapes. And in order to do that, you can see right here, the instructions tell us that we need to draw in the diagonals. Now, the good news is by doing these rotated triangles, we've actually already got one of the diagonals drawn in. You can see I highlighted those there. So you want to grab a ruler and you want to draw in the other diagonals as well. So like, for example, since we already know the one diagonal I highlighted there, I'm gonna do this one in kind of a pink color. So we'll draw in the other diagonal like that. So what you're going to do is the video will pause, and you're going to draw in the other diagonals and make sure you and your teammates are all caught up. You've got everything correct. You get your other diagonals drawn in on the other three examples, and then we will continue on. So you should have the diagonals are all drawn in now on the four examples, as you can see here. So you've put in those extra lines across from corner to corner. And so now we want to answer some of these questions in regard to the diagonal properties. Now we can get real specific about the math and figuring out some of these things here, but fortunately for you, I'm not going to make you do all of that. We're actually just going to use our patty paper and do some measuring to try to come up with this information, since we're just doing this exploration. So let's just kind of talk a little bit about how we're going to do that. So you're going to take your patty paper that you have, and you're just going to use some of the outside leftover pieces of it that kind of match along. So if you take your patty paper here, you know, you might, and again, mine's not drawn on, but you know, yours would be. So just find like some extra space somewhere on your patty paper. You know, so if we wanted to figure out, you know, if the diagonals bisected each other here, we could just take our patty paper, put it over here, just use it, to do some measuring, so that kind of thing. So I'm just going to kind of leave my patty paper over here so that I don't cloud up what I'm drawing. But you can see here, if we wanted to know, do the diagonals bisect each other? Well, then, you know, just use a piece of your patty paper and just kind of, you know, measure, you know, like maybe down here on the side or something like that. You want to measure this distance right here, and then use the patty paper and, you know, line it up. Does it line over the top of this? If they're exactly the same, then yeah, then, you know, they've been cut into two equal parts, right? That's the bisecting each other. are the diagonals themselves congruent? So with that, you would want to take your patty paper and you want to measure this whole diagonal here. Is that congruent to this whole diagonal here? Now, obviously, some of these are going to be very easy to see. Like, it's very clear that this line is way longer than this line right here. So in that case, we can say no, and that one, the diagonals are not congruent. But again, remember that with all of these, you've got to check all 4 examples to see, does it apply here? Does it apply here? Does it apply here? Does it apply here? So you're going to be checking those for all of those. So let's talk about this one right here. The diagonals are perpendicular. Okay, so what we mean here when we say diagonals are perpendicular, it means that where the 2 diagonals cross each other, do they make a 90-degree angle? So in other words, is this intersection right here a 90-degree angle? And you can actually use that, you could actually trace a 90-degree angle on here, and you can use that to kind of measure. This one's pretty clear that it's not a 90-degree angle. So, you're going to need to check where the diagonals meet here, and then again, where the diagonals meet here. And, you want to determine, did you come up with a 90-degree angle? It's got to be there in all 4 cases in order for you to check the yes box, right? So just make sure that you check the yes box. And then let's talk about this last one. Diagonals are angle bisectors. Okay, so what that means is that the 2 opposite angles, right? Diagonals connect opposite angles. The 2 opposite angles get cut exactly in half. So I'm going to give you an example over here. So for example, this diagonal right here, if it were an angle bisector, what that would mean is that this angle and this angle got cut into 2 equal parts. Again, you can just use a corner of your patty paper and just sort of trace one of the angles like that, and then, put it over the top. So like, for example, you might use a corner of your patty paper and trace this angle right here, and then you can line it up against this angle right here, and then ask yourself, are those 2 angles congruent? If they're not congruent, if they're not the same, then no, that angle of the parallelogram, this whole angle right here, did not get bisected, right? Remember, bisect in geometry means to cut into 2 congruent parts, right? So you're going to be checking all 4 angles. Now, some of them, again, you can see from the markings. Like, take, for example, this one right here. This is the diagonal, right? And it's cutting here these opposite angles. Well, it's pretty clear that those aren't cut into 2 congruent parts. This side is 90 degrees as by the marking, and this side is 45 degrees. So in that particular case, the diagonals are not angle bisectors. So just want you to verify that on each one of these. You can see where they are angle bisectors or not, and then you're going to go ahead and mark your yeses or your nos, okay? So the video will pause, and then you'll answer the questions and verify and check those right there, and then we'll pick up. So it should have been pretty obvious with this one that the only one that was yes on this were the diagonals bisecting each other. In each of these cases here, these were all no's, and hopefully you answered those questions correctly. So let's get back to then our summary of this, what quadrilateral is found out here in all 4 examples. So you should see that we've got 5 yeses. We've got 2 yeses on the sides, 2 yeses on the angles, 1 yes on the diagonal. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. That should sound pretty darn familiar, given what we've been working on the last few days. And if we go back over to our little family tree over here, and I told you we were going to be talking about, this parallelogram family in here. We're going to be looking at that. Obviously, this one is the father of the family tree. This is the definition of a parallelogram. That's the properties that stand out to us. So we're able to actually verify those properties now mathematically. So then for this one, we would say what quadrilateral is formed in all 4 of these examples? This is a parallelogram. All right, now we're going to move on to the second part of our exploration. So let's go over to the back of page 2. So turn with me over here now to page 2 here, page 4, whatever on the actual page numbers. And again, so, now that we've done this, I'm going to do a little less guidance with you. You're going to work with your shoulder partner and you're going to work with your team because now you know how to do this. So, we'll just kind of stop and check in and answer some questions together just to sort of help kind of keep you moving along and make sure that you're completing this and doing all the things that you need to get done. So the first thing that I want you to do is I want you to, use your patty paper. You'll use a new clean piece of patty paper on both of these examples here, and you're going to get your triangles rotated around 180 degrees and drawn in with all of the the marks. And why don't you go ahead and figure out your slope calculations and write all that information in so that you have that as well, so that we can just jump right in and talk about side properties. So right now you're going to take your patty paper and you're going to complete these two examples, rotating the triangles, putting in all the markings and doing all the slopes, and then we'll pick up from there. All right, so I've got my triangles rotated and drawn and marked up, and my slope calculations in there, which you should have as well. So you should have that on your diagram. Again, make sure you're completing all of this. This is all going to be required for you to receive the grade for the assignment. So let's talk about side properties now. Okay, so side properties. Now you know how to figure this stuff out right here. So I'll pause this and ask you this question about the side properties. You guys talk about it with your shoulder partner or your small group, and then we'll come back and see how you did on side properties. Okay, so this time we have 3 yeses on side properties. We've got our sides are parallel. We were able to verify that with our slope. I can see our single markings here are both slope of -2, and our dual markings here are both slope of 1/2. And then down here, of course, we have the 2 vertical lines with the undefined slope and the 2 horizontal lines with the 0 slope. So yeah, opposite sides are clearly parallel because our slopes are the same. Opposite sides are congruent. That's pretty easy to tell from the congruency marks. Adjacent sides are perpendicular. You should be able to see adjacent, again, when we talked about those are the 2 sides that share a corner. So these 2 sides are perpendicular. These 2 sides are perpendicular because you can clearly see the 90-degree angles. And then if you just use your patty paper to measure, you'll see that this also is 90 degrees. This also is 90 degrees. Same thing here, 90 degrees, using the patty paper to measure. Again, using patty paper to measure 90 degrees. And then these, of course, are 90 degrees, saying that these adjacent sides are also perpendicular. So yeah, in these examples, all of the adjacent sides are in fact perpendicular. And then of course, the last question, do we have 4 congruent sides on the shape? No, of course not. We don't, because we've got different markings, right? We've got a 2 marking, a 2 marking, then a 3 marking, a 3 marking, and different markings up here as well. So no, in that case, the 4 sides aren't congruent. All right, so now we're going to move on to the angle properties. So again, you'll use your patty paper or your reasoning as far as, the markings within the shapes themselves. And, I want you to answer these 4 questions. And so I'll put the question up here on the right side. When you have those, check them off and answer that question, and then we'll grade it together. All right, so this one should have been straightforward. Opposite angles congruent, consecutive angles are supplementary, and do we have 4 90-degree angles? Yes, 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 and yes, all the way around. These are all yeses, of course they are. And we sort of already knew that, right? Because we had already determined that adjacent sides are perpendicular, which means that we had the 4 90-degree angles. And then, of course, if you have 4 90-degree angles, obviously consecutive angles are going to add up to 180 degrees. Obviously, opposite angles are going to be congruent. So some of this becomes, intuitive when you figure out certain pieces of information. And hopefully you're beginning to pick up on that. Okay, so we're going to talk about now the diagonal properties of the quadrilateral, which means that you need to go ahead and draw in your other diagonals here and then potentially use your patty paper to measure those. I'll let you take care of all of that, and then we will come back and answer some questions on these right here. All right, so use your patty paper to do some measuring and draw on your diagonals. All right, hopefully you got those right. Diagonals bisect each other, so you can. And I'm just going to use this one example here, so I don't have to keep scrolling off of this. But if you measured these out, you'd see that that is exactly the same length as this, and so on and so forth. You should have been able to figure out, though, that these lines are actually congruent to each other, and you could have done that with your patty paper measuring it. So yes, the diagonals are congruent in this particular case. No, they don't intersect at a 90-degree angle. That is not a 90-degree angle there. And those angles are not cut into two perfect parts. They're not bisected like that. So you had 2 yeses on the front end and 2 yeses on the back end here. So as we take a look at this quadrilateral now, think in terms of, let's kind of come back here and look at the family again. I think you probably know which one this is, but of this family right here, which one do you think that is? Why don't you go ahead and take a shot at that, and I'll put the right answer here in just a second as which quadrilateral is formed. It's going to be one of those. And the winner is, of course, rectangle. So this is a rectangle. And so now what we can do is we can then begin to determine what is it about these properties that makes a rectangle, as opposed to just a generic parallelogram. Well, that's where we leave out the 5 first properties, and I'm going to cross these out in here just so that you can see them. But you could cross them out on your paper too, just to kind of give you an idea as well. So the 5 properties that were part of the just generic parallelogram, right, are the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. The ones that I kind of crossed out on my paper there lightly, you can see those are the properties of a generic parallelogram. So then what makes a rectangle unique is that we have adjacent sides are perpendicular, there are 4 90-degree angles, and that the diagonals themselves are congruent. All right, so when we talk about what is it that makes a rectangle unique, it would be the yes qualities that show up that are not part of the general parallelogram. All right, and so that's how we're going to be able to determine the difference between a rectangle by way of using these properties words. We can use that to say, hey, this is what makes a rectangle unique. The adjacent sides are perpendicular, there are 4 90-degree angles, and the diagonals themselves are congruent. Okay? All right, moving on to our next exploration. So now we're pretty much getting old hat on this, so I want you to go ahead and take these 3 examples right here, and you're going to do your rotating triangles and slope markings and all of that kind of stuff. Get that done, and then we will jump into talking about side properties on this one. All right, so you can see the slope markings are all put in there, and the triangles have been rotated and marked up, and I have all the pieces there. So we're going to go ahead and now work in on our side. Actually, here, let me just give you a chance to kind of take a look at those pictures here. So there's the first one. You can check your slope markings and your markings on the second one there, and then down here on the third one as well. So again, we're going to be talking about now the side properties, right? So we're going to be looking at these right here. Again, you want to determine, are the opposite sides parallel? Are they congruent? Are the adjacent sides perpendicular? You could actually trace, another 90-degree angle from here, since none of the shapes actually have a 90-degree angle marked in them. You could just trace one of those on a patty paper and use that to check. And then, do you have 4 congruent sides? So we'll put that question up for you to answer. Go ahead and talk about it with your partner and your team. And then evaluate those, put your check marks in, answer the question, and then we will talk about angle properties in just a few minutes. So with the slopes all being the same, then our opposite sides are parallel. You can see that we've got congruency markings. The opposite sides are congruent, and actually all the sides are congruent, right? So we do have 4 congruent sides. And then if you checked the adjacent sides, again, adjacent sides are the sides that share a corner, right? They're not opposite, like this is opposite from this across the room. Adjacent sides share a corner. If you check those, you'll see that that they don't match up at 90-degree angles. So that one is a no-go on that one. All right, so now we are ready to then talk about the angle properties of these types of quadrilaterals. So again, we'll put the question up on the side there. You work with your partner and or your teammates and come up with the answer to the angle properties. So opposite angles are congruent. That's a yes. You can see that, right? So then we've got a solid dot. We got a couple of hollows, and that is actually modeled in the other ones as well. So our opposite angles are congruent. Again, our consecutive angles are adding up to 180 degrees. Again, that same pattern. We've got 2 hollows and a solid in those consecutive angles, and then again, 2 hollows and a solid in this triangle. And since the angles have to add up to that 180 degrees, we can use 2 hollows and a solid to come up with 180 degrees. So yes, we have that. And we do not have 4 congruent angles. We don't have the 90-degree angles in this one. And so that's a no-go here on that one. So hopefully you got those right, and things are starting to move pretty smoothly for us in this exploration. Of course, up next again is the diagonal properties. So we want to draw in our diagonals. and then I'll put the questions up for you to answer in regard to the diagonal properties. So we're going to be working on these questions right here. So you'll need to draw in your diagonals and then go ahead and answer those questions with your partner or team, and then we will take a look at those answers. All right, diagonals are drawn in, and of course, you were given your answers. Let me check mark those for you here. So the diagonals do bisect each other. We saw that. The diagonals are congruent. No, they are not. Clearly not the same length. The diagonals are perpendicular. Yes, this one is actually true. And the diagonals are angle bisectors. So if you measured out these angles, so the interesting thing about these diagonals here is that they do meet at a 90-degree angle. And so if you had checked a 90-degree angle from here and measured the diagonals, you would have saw that they do in fact meet at a 90-degree angle. And if you had measured out these angles right here and traced them, you would have found that those angles are congruent. We can see that here with the hollow circles right here. You know, this is hollow circle measurement, hollow circle measurement. So we know that the diagonals do split those angle bisectors. And so this is the layout right here. All right, so now let's kind of summarize this again like we did with the last one. I'm just going to go through and I'm going to lightly cross out the characteristics or the properties of the general parallelograms, right? So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Again, the ones that I'm just lightly crossing out on here, those are the ones that are properties of the general parallelograms. And then we can take a look and see what else stands out from a yes perspective. All right, so from a yes perspective, this particular shape is a parallelogram because it does meet all of those characteristics, those 5 characteristics of a parallelogram. It is a parallelogram, but it's a parallelogram with 4 congruent sides, and the diagonals are perpendicular and the diagonals are angle bisectors. So this is a special kind of parallelogram with 4 congruent sides, and we've got the diagonals are perpendicular and the diagonals are angle bisectors. All right, so then going to our family tree again over here, and the quadrilateral, the parallelogram family that we're talking about over here, we've identified 2 of our parallelograms. I think you can probably pick out which one this one is. That is correct. This one is the rhombus. All right, this is probably the one that's least understood as far as the characteristics go. So this will be an important one for you to study. So let's go ahead and put that name in here. So this one is the rhombus. And so the rhombus is a special kind of parallelogram that has 4 congruent sides, and also the diagonals are perpendicular and the diagonals are angle bisectors. All right, so the big secret is out of the bag now, obviously, on what the 4th one is, but we still want to do the observations and mark up our properties and just kind of compare and see how they relate. So we're going to do this last one now. So again, you're going to be working on getting these examples right here, rotated, copied, marked up, sloped, figured out. Again, all those markings are important for your grade on this particular exploration as well. So go ahead and work with your partner and team to get the drawing set up so that we can then talk about side properties. All right, my triangles are rotated, my slopes are figured out. Like I said in the last section of the video, the cat's sort of out of the bag. We can call this what it is. We know this is a square, but what we really want to be able to get to is be able to define these shapes that we've been talking about and that you've heard of since, 3rd grade. We want to be able to define them by their specific properties. And that's what we're trying to get at here. And then it also becomes kind of interesting because, then I'm going to begin to ask questions like, well, hey, is a rectangle a square, or is a square a rectangle? And you need to be able to defend that answer. Which is one of those true? Are they neither true? And if so, can you defend them with the properties, which is the goal of this? Okay, so you've got your first tackling task here is to go after the side properties. So let's see if you can figure out what the side properties are here. So in this case, we've got the home run right here. The side properties, all of them are yeses. Opposite sides are parallel. We've verified that with our slopes. As you can see here, opposite sides are congruent. We get that from our congruency markings all the way around our shape. Our opposite sides are congruent. Our adjacent sides are perpendicular. We don't even need to measure those because we see 45 plus 45 is 90, and we have the 90 markers here. And of course, we have our 4 congruent sides. So in this case, all our side properties are yes. All right, so then now what we want to do is tackle the angle properties. So we want to take a look at the angle properties here. So we'll pause and give you an opportunity to work with your partner or team to check those and see what you come up with. All right, so again, we have the full yes column checked here on our angle relationships. So our angle properties, all of our opposite angles are congruent. Our consecutive angles add up to 180 degrees. Of course, they would, because we have 4 congruent 90-degree angles in each of the shapes over there. So yes, all of our angle properties come into play here. All right, so we're almost done with our exploration here. You just need to draw in your diagonals on your 2 shapes, and then, of course, answer the diagonal properties using any measurements that you need to use or cues from the diagram. So we'll look at those next. All right, once again, we have all yeses here when it comes to our diagonals. Again, the diagonals bisect each other. We can see that, of course, with the parts being congruent to each other. The diagonals are, in fact, congruent. If you measured those out with your patty paper, you would have found that they are congruent in both cases. The diagonals are perpendicular, so they do meet at 90-degree angles where they meet. And the diagonals are angle bisectors, and we can see that in the measurements, and we can see that here with the 45 split. So yes, all of these characteristics come into play. So now we can see something kind of interesting beginning to develop here with the square. All of these properties that we've explored come into play. So the goal for us now is to take this exploration and then begin to sort of organize the data that we have. So once you have your exploration here complete, you're going to want to get it to me so that I can get you the next part of the project. Okay? All right, good job.